In our last section, if you looked at that one, we developed formulas for the variance and the standard deviation when the data was given individually. Now we're going to take a look at those computing formulas when the data is given in a frequency table. Here's what we had before. We had the variance was, now this is a computing formula, n times the summation of the x squareds, right? Take each data value and square it, then add them together, multiply by the number that you have, minus the summation of the x's. So add up all the data values, get a sum, and then square that result, divided by n times n minus 1. That was the variance. In fact, it was the sample variance. Then we just took the square root of all of that, and we got the sample standard deviation. So it's the square root of the n, let's write that better. Then we'll square these x's, the sums, and then divide by n times n minus 1. And this was the sample standard deviation. All right, now that was fine. Those formulas work well if you're given individual pieces of data. But if the data is in a frequency table, we need to change things up a little bit. So I'm going to rewrite those. I'm going to write them right up here at the top. So they're just going to be a little bit different here. So what we're going to have here is, right, n times, now just a slight difference here. Instead of just the, instead of just the x squared, since the data is in a frequency table, we have to account for how often each piece of data occurs. So we take f times x squared. So now look what you're going to do. You're going to take the piece of data, square it. You're going to multiply it by the frequency, how many times it occurs. Right? So you take each piece of data, square each piece, multiply each piece by its corresponding frequency, and then add up all those numbers. Then we'll subtract. Now, instead of, what are we going to put in here? Instead of just the sum of the x squareds, we have to incorporate the frequencies. So no big deal. We just add up the f times x and then square that. And it's still all over n times n minus 1. And then if we take the square root of all that, we'll get the standard deviation. So we get n times the summation, try to write that so it looks good, of fx squared minus the quantity, the sum of the fx's squared, all over n times n minus 1. All right, so these are the computing formulas for the sample variance and for the sample standard deviation. Not to worry, we'll look at an example. Let's write an example here where the data is going to be given in a frequency table. So suppose we have this. Now I'm just going to write the class number so I can keep track of which class I'm talking about. So the class number, and then let's put in the class limits. You know, that looks like a D, not a C. Class limits. And then the class mark, which we know is the midpoint, right? Instead of saying midpoint, we say mark. And then we've got the frequency. Okay. Now, suppose our data look like this. We've got 6 classes, say 1, 2, 3, 4, 5, and 6. And our limits, our classes go here. 5 to 19, 20 to 34, 35 to 49, 50 to 64, 65 through 79, and 80 through 94. Now here's the class marks. What do you get for this one? 5 and 19 is 24, divided by 2, we're going to get 12. And what do we get here? 20 and 34 is 54, divided by 2, you get 27. Now, how far are those apart? Those are 15 units apart. So if I just add 15 to 47, to 27, right, 27 and 15, that'll give us 42. And you can check that. 35 plus 49 divided by 2 is going to give us 42. Then add 15 again, we're at 57. Add 15 again, we're at 72. Add 15 again, we're at 87. And just suppose, now I'm just making these up. Suppose that, what we're thinking, okay, I've got 12 pieces of data in this first class here. Well, I'm sorry, that's not what I have at all. I've got a 12 that appears in here, and how many of those do we have? Let's just make it up. We got 4. So I'm saying that there are 4 pieces of data in this interval. I don't know what they are exactly, but I'm going to assume that they're all 12s. Now, let's just write up some numbers. Suppose there's 12 pieces of data in the second class. There's 15 in the third, maybe 16 in the fourth, 22 in the fifth, and maybe only 11 in that last class. Now we want to compute this variance, all right? So look at the formula. That's why it's good to have the formula in front of you so you know what to compute. Look what you need here. You need the x's. You need the f's. So I'm going to have a column for the x's, a column for the f's. Then I need the x squareds times the f. Okay, so maybe I need an x squared column too. So let's write all of this up. I'm going to build a table that looks like this. X squared, f. Then I need, I'm going to leave a little bit more room. Then I need one of these, f times x. And then I need the fx squared. Okay, I see what I need in my formula. So I'm going to write a column for every individual one of those, right? So look at the formula here. What do you need? Well, you need the x's, so I'll have a column for the x's. You need the x squareds, so I'll build a column for the x squareds. Then I need the frequencies, right? I need frequency, I need the frequencies, so build a column for the frequencies. Then I need the frequencies times the x's, fx. So I'll make those multiplications, right? Just f times x. And then I also need the f times x squared. So the f times the x squared will go right over here. So let's write our x's. All right, so the x's, these are the class marks, right? These are the class marks. So we have 12, 27, 42, 57, 72, 87. Now, we need to square each one of these. So 12 squared, I know that one. That's 144. 27 squared, I don't know that one off the top of my head, but I can get it. 729. And then 42 squared, that's 1764. 57 squared, I'm doing this on my TI-84 calculator, 3249. 72 squared, 5184. And finally, 87 squared, that is 7569. All right, now the frequencies. All right, I'm given the frequencies right here. That's in that table right there. So the frequencies are 4, well, let's get it to right, 4, 12, 15, 16, 22, and 11. Now we need to make some multiplications here. All right, f times x. All right, now I'll show it. It's going to be 4 times 12, so I get a 48 out of that one, right? Okay, and then what do we get here? F times x. So I had 12 times 4. Okay, and then what do we have? Where are we? F times x. 12 times 27. Okay, so this is going to be, I'll write it here, 12 times 27. Okay, that is 324. I think you see how to get those, so now I'm just going to do it. So the next one is 15 times 42. Now 15 times 42 is 630. And then the next one, f times x, 16 times 57, that is 912. Then f times x, 22 times 72. My calculator says that's 1584. And then finally, 11 times 87. Now, my TI-84 says that's 957. Okay? Well, now I need the f times the x squared, okay? Fx squared. So here's f, here's x squared. So make those multiplications. 4 times 144. Okay, I'll show the first few. 4 times 144, that turns out to be 576. All right, the next one, f times x squared is 12 times 729. All right, so this is 12 times 729, barely readable, 8748. I'm just going to write the rest of them down. 8748. Okay, the next one, 15 times 1764 is 26,460. And then 16 times 3249 is 51,984. And the next one, 22 times 5184 is 114,048. And finally, the last one is that 11 times the 7569. And I got 83,259. Now, look what your formula says, all the way up here at the top left. We have to add some things up, right? So what do you have to do? You have to add up the fx squared column. I have to add these. Then I have to add up the fx column. fx, I have to add up that one. Okay, anything else? Yeah, you know, what is this n? N is the sample size. Now, what's the sample size? Well, look at frequencies here. You got 4 data pieces in this first class, 12 in this one, 15 in this one. So if I add all these up, I'm going to get n, right? So I'll just make a note of that. So n is equal to the sum of the f's. Let's add them up. I'm not going to add up anything I don't need. I don't need to add up the x's, right? There's nothing in the formula that says just add up the x's, right? There is nothing in this formula that says this, add up the x's, or nothing that says add up the x squareds. I don't need those, so don't do it. Add up the f's. If I add up the f's, okay, I'm going to add this column right here, and when I did that, I got 80. Now, I also need to add up the fx. Oh, add up the fx. So I come down to the fx column. I need to add that one. So that's, I added all those on my calculator. I got 4455. And then I have to add up what else? I have to add up the fx squared. Fx squared. Add up the fx squareds. I got all the fx squareds here. So if I add all those numbers, I get 285,075. Okay, I've got them all added up. Now, plug them into the formula and compute. So s squared is going to be, all right, big fraction here, n. Now, n, that's what? That's our sum of the frequencies. 80. All right, so I'm going to get 80 times fx squared. So 80 times what? Fx squared. That is this number here, 285,075. Okay, let's get that. 285,075 minus, okay, minus what? The sum of the fx. There is the sum of the xx, but I need that squared. Okay, so 4455 squared. all over n. Now remember, n is 80 times 80 minus 1. Okay, be careful here. Okay, n is not equal to 6, right? Where does that 6 come from? You might be thinking, oh, I've got 6 classes here, right? 6 classes. No, it's not the number of classes, it's the number of pieces of data. And I've got 4 in the first class, 12 in the second class, 15 in the third class, and so on. So altogether, I got 80 pieces of data. Calculator problem. Let's get this into our calculator. So look, what you've got here is a fraction up at the top right. You got a top and you got a bottom, and there's operations, right? You got a multiplication, subtraction, and so on. So whenever you have a fraction, you want to use parentheses to capture the entire top, the entire bottom. So on your calculator, type in a left parentheses right above the 8, then type in 80, press the times key on the right-hand column, type in 285075, all right, no commas, minus 4455 caret 2, up arrow 2, and then close the parentheses right above the 9. Now, this thing right here, that's how you tell the calculator to raise this to the second power, right? Raise it up to that power. And on your calculator, if you look at the very bottom right, it says enter. Then it says plus, minus, times, divide, and there it is right there. Okay, now what do you want to do? You want to take all of this result and divide it by that denominator there. All right, let me get rid of this. So you're going to press the divide key. You get a slash. Now look at the denominator. There's an operation, right? You have right here, you got a multiplication. Now, I'm not going to type 80 minus 1. We all know it's 79. But you do have a multiplication, so use parentheses. 80 times 79. All right, that's how to put it in properly. Now, when you've got that in, press the enter key, and you're going to get S squared, and I am getting 468.19. I'm just going to leave it at that. So there's the variance. I've got the variance. Now, that is on my calculator. So when I look at my calculator, what's on my screen here? On the right side of the screen is 468.19. Now, I want the square root of that. So down here, right here, you're going to press the second key. All right, press the second key. And then down a little ways, you'll see a key that says x squared. Right above it, it says square root. So if you press second, here's what you're going to do. You're going to press second, and then down here you're going to press that square root key. That gives you this, the square root. And then you want that 468.19. Now, you can type that number in, or you can do this. Right, you can just go ahead and type it in, 468.19, or, you've got that square root, and then type in, all right, up here on your calculator, press the second key, and then down here at the bottom right, what is that? Down here at the bottom right, you have that enter key, but right above it, it says entry. All right, so press the second entry, and what you get is the answer. It just pops in ANS. It pops in the last answer that you computed. All right, so you don't have to type it in yourself, especially if it's long. All right, and then anyway, what you're going to get out of that, at least when I did mine, I got 21.64. So I'm getting S is equal to 21.64. And I think I'll just leave it like right at that. All right? So here's what I'm getting for these two things. The variance, I got to be 468.19, and the standard deviation, I got 21.64. There we go.